When we talked about first derivative approximations, we essentially had either backwards or forwards or central differences around a point xi. So we had a point at which we wanted to evaluate first derivative, and then we looked at another point to the left of it, sort of xi minus 1, and another point to the right of it, xi plus 1. We're going to continue with this theme, but now we're going to talk about second derivative approximations. So essentially we have the formula, in fact, a 3-point central difference formula for second derivatives. So a second derivative at a point x can be approximated with the following. We can approximate it as f of x I minus 1 minus 2 f of xi plus f of x I plus 1, like so, all divided by delta x squared. Remember, delta x is once again the distance between these points. So it's really delta x here, and similarly delta x here. Here we're squaring delta x. So this is our formula, and we can now try applying it to estimate certain second derivatives. So let's imagine that we have a function defined as follows. Let's have a function 3 to the power of x divided by 3x. Okay, so we can certainly, let's suppose we want to find out the derivative, the second derivative at a point x equals 3. Now, first of all, what I can do is I can just tell you what the actual value is, because we can get an analytic solution. In this particular case, we can just differentiate the function twice and apply the x equals 3. So I can tell you that the analytic solution is somewhere around 2.0903. But we're going to do it using the approximation method, the approximation formula that's described here. So once again, to get the f of x, f of xi values, we need to calculate them basically. So we have x values. I'm going to, if we're going to calculate this at x equals 3, what I'm going to do is I'm going to decide that delta x is going to be 0.3. So essentially we already have the value at xi, that's the 3, that's the value we want to calculate, and then xi minus 1 is going to be 3 minus the delta, so that's 2.7. And similarly, we're going to have xi plus 1, that's going to be 3 plus the delta, so that's 3.3. Okay, so we want to have these values calculated for us. So that's going to be the actual x values are going to be 2.7, 3, and 3.3. And if we calculate the function at these particular points, we're going to get something like the following. We're going to get 2.3974, 3, and 3.792. So armed with this data, what we can do is we can plug these values into this formula here, and we can try and calculate the second derivative. So essentially, the second derivative here, just to illustrate how to plug in all these values. So the second derivative at 3 is actually equal to the function at 2.7 minus 2 times the function at 3 plus the function at 3.3, all divided by delta x squared, so that's 0.3 squared. And we already have these values. So this value goes in here, this value goes in here, and this value obviously goes in here, and we plug those in, and the value we get is something like 2.1042. So you can see that it's reasonably close to this value. It's not exactly the same. We can actually calculate the error. So in this case, the error is equal to 2.1042 minus 2.0903 divided by 2.0903. So that's equal to 0.665%. So actually pretty good. So the results, these results, they basically show that the 3-point central difference formula gives a very accurate approximation for the value of the second derivative.